Textbook exercise 3.11. This question gives us a utility function, which is a perfect substitutes utility function. U of Q1, Q2 equals Q1 plus 2Q2. And it asks us to find the compensated demand for good 1. The way we're going to do this is to solve for the expenditure function and then use Shepard's lemma to back out the compensated demand. So the first step, like I said, is to find the expenditure function. Remember, the expenditure function is essentially the minimization of expenditure, subject to the constraint that you attain the utility level U bar. So your expenditure at the prices P1, P2, and the utility level U bar is the least expenditure in order to attain the utility level U bar. So how do we do that? Well, remember, we have perfect substitutes utility here. So we're always going to end up with these corner solutions. So let's not try to write down a first order condition because that's not really going to help. Let's just use common sense instead. So if I want to, as cheaply as possible, get to the utility level U bar, well, what I'm going to do when I have perfect substitutes utility is to look at the two prices. If the price of good 2 is less than 2 times the price of good 1, then I'm only going to buy good 2. Otherwise, I'm only going to buy good 1. Why is that? Well, in order to get 1 unit of utility, utility is measured in the unit of utils. This is some fictional unit, but if to get 1 unit of utility, I need either 1 unit of good 1 or a half a unit of good 2. How much does it cost to get 1 unit of utility then? Well, if you're going to buy a unit of good 1, well, that's just going to cost you P1. On the other hand, if you're going to buy a half a unit of good 2, that's going to cost 1/2 P2. So the cheapest way to get an extra unit of utility, or 1 unit of utility, depends on P1 and P2. So if P2 over 2 is less than P1, or in other words, 2P1 is greater than P2, then the cheapest way to get an extra unit of utility is to spend $1 on good 2. That's why you only buy good 2 if P2 is if P2 is lower than twice P1. Conversely, if P1 is less than half of P2, in other words, if 2P1 is less than P2, then buying good 1 is the cheapest way to get utility, so you're only going to buy good 1. So if you only buy good 2, how many units of good 2 do you need to get this target utility level U bar? Well, remember, for every unit of good 2 that you buy, you get 2 units of utility. So by purchasing U bar divided by 2 units, or a half U bar units of good 2, you get 2 times U bar over 2 units of utility, which is U bar. So how much does that cost? Well, it costs U bar over 2 times P2. On the other hand, if you only buy good 1, how many units of good 1 do you need in order to get U bar units of utility? Well, for every unit of good 1 that you buy, you get 1 unit of utility. So to get U bar units, you just need to buy U bar units of good 1. And those are going to cost U bar times P1. So your expenditure function is U bar over 2 times P2 if P1 is bigger than P2 over 2. U bar times P1 if P1 is less than or equal to P2 over 2. Okay, so now we've got the expenditure function. How do we get the compensated demand? Remember, Shepard's lemma tells us that the compensated demand for good 1 is just a derivative of this thing with respect to good 1. So all we have to do is take the derivative of what we had on the previous slide. So if we take the derivative of this with respect to the price of good 1, it's 0. Take the derivative of this with respect to good 1, it's just u bar. That's what we find here. So if P1 is bigger than P2, then Hicksian demand, or the compensated demand for good 1, is 0. If P1 is less than or equal to P2 over 2, then Hicksian demand, or compensated demand for good 1, is u bar. So that's how you find the compensated demand for a given pair of prices and a utility level.